Okay, guys, sorry about that. Let's continue. I think my network is having an issue somewhere, somehow. So we were saying that here they say that we should determine the number of moles X of water of crystallization. So we were saying that we are given 10 grams crystals of copper sulfate, and then it is forming 6 grams of anhydrous copper sulfate and then some water. So we want to calculate the number of moles of what? Of water of crystallization. So this is where we say that the total mass that we had should be conserved. This is from the law of conservation of mass. So 10 grams has to form 6.4 grams of copper sulfate, and then the remaining will go to water. So how much will go to water? We say 10 minus 6.4 being equals to 3.6 what? Grams. Now, after that, we would actually get to want to know the molar ratio that we have for copper sulfate and the hydrated what? And the hydrated water. So we are going to say that mass over molar mass, which is mass over the molar mass of copper sulfate, which is 6.4 grams of what? 159.5, we get 0.04 moles. And then if we say the number of moles of the water of crystallization, that is 3.6 divided the molar mass of water, which is 18, and this would get to say that it gives us 0.2 moles. So in terms of the molar ratio in between the copper sulfate and the what and the water of crystallization, we are going to see that we are having what? 0.04 is to what? 0.2. So we now get to divide by the smallest, which is 0.04, and then 0.04. We are going to have what? 1 is to 5. So this is the mole ratio that we are going to have there. So our hydrated water would have what? 5 moles. So X there was just supposed to be equal to what? To 5. So our X was going to be equal to what? To 5. That is how we calculate the what? Number of moles of what? Of water of crystallization. Now let's go to the next question. So the next question, they've now given us this experiment. Like I was saying, that you see that they will usually get to repeat questions. They like this experiment. I do not know why. Where they will be actually getting to say that grade 10 learners conducted an experiment to investigate the effect of the increase in temperature on ethanol over a period of time at standard pressure. So they like this experiment where they want to investigate the effect of the what of the increase in temperature on ethanol using the kinetic what theory of matter. So let's see what they are saying on the following questions. So here we've been given a graph, and they're saying the graph below was drawn using the results obtained from that experiment. The experiment was heating what? Ethanol, to see the effect of temperature on the what? On ethanol. We want to see the effect of what? Of temperature on ethanol. So you definitely get to see that as we heat our ethanol, it will either increase its temperature up until we reach its melting point, and then on its melting point, we are going to have a phase change under a constant temperature, changing from solid to liquid. And then once all the solid has been transformed into liquid, we are now also going to continue having what? Temperature change up until we reach the what? The boiling point of ethanol, and ethanol will now start boiling, which is transforming from liquid to a gas. Up until all the liquid has been transformed to gas, we are also going to have an increase in temperature as we are going. So as we are continuing to heat, we want to observe what would be the effect on ethanol. So here they're saying define the term melting point. Melting point, this is the temperature. This is the temperature at which a liquid transforms into sorry, a solid transforms into liquid. Here I'm now saying that a liquid. So this is the temperature where we have got phase change. So we are saying that temperature at which a solid, at which a solid transforms into liquid whilst our temperature remains constant. So this is at what? At standard at standard pressure. So the temperature at which a solid transforms into liquid at standard pressure. So the pressure has to be kept constant. The pressure has to be what? A constant. So that we can say that if we are to repeat this experiment, we'll get the same results, the same melting point. Now we are saying write down the value of the standard pressure. What is the standard pressure? The standard pressure that is usually used, it's what? It's 1 bar. We usually take our standard pressure to be at sea level. At sea level. So the pressure at sea level is usually what? Atmospheric pressure, which is either 1 atmosphere or else 1 bar or else what? 101.3 kilopascals. That is what we refer to as what? Standard pressure. So our standard pressure is usually taken what? At sea level. So at sea level, the pressure is the pressure of the atmosphere, which is what? 1 atmosphere or else 1 bar or 101.3 kilopascals. So that is the value that you are supposed to write there. Now they are now saying, give the name of the apparatus X. Which one is the apparatus X? This is the apparatus X. So you can see that the apparatus X is the one that is used to measure what? Is the one that we are using to measure our temperature. So what is used to measure temperature? It's a thermometer. So a thermometer is the apparatus that we use to measure what? To measure temperature. That is apparatus X. So here you are supposed to say what? Thermometer. So there you are supposed to say thermometer. And then here they are saying, in what phase is ethanol at 0 degrees Celsius? So from the graph there, I'm sure we can all agree that our ethanol melts at what? At negative 115 degrees Celsius. So if our ethanol is melting here at 115 degrees Celsius and then later boiling at 78 degrees Celsius, it means that during this whole region here, it's a what? It's a liquid. So ethanol is a liquid at what? At 0 degrees Celsius. It's a liquid. And then they are saying, explain using the kinetic molecular theory what is happening at D. At D, we can see that there is what? As our temperature is progressing with time, as our time is progressing, sorry. So we are saying that as our time is progressing, our temperature remains constant. So we are saying as our temperature is progressing, our temperature remains constant. As we have mentioned that this is the boiling point of what? Of ethanol. So we're just going to say that at D, there is phase change. There is phase change. And the phase change is occurring at what? At constant temperature. So at D, there is phase change at constant temperature. That is to say, the heat that is continuously supplied is being used to overcome the intermolecular forces of a liquid so that it can actually get to what? So that the particles can break away into a gaseous state. They are used to, the heat is used to overcome the intermolecular forces of a what? Of a liquid. The intermolecular forces of a liquid. So hence the liquid is hence the liquid is transformed into a gas. So we are saying that there is phase change from liquid to gas. And how is that occurring? It is occurring at a constant temperature, meaning to say that the heat that we are continuously supplying here is being used to break through the intermolecular forces of what? Of a liquid, so that our particles will gain energy to become what? To become gaseous, where we know that a gas is always in a random what? In random state of motion. That is what is happening at D there. Now they are saying, will water or ethanol boil first at standard what? At standard pressure. So at standard pressure, we know that ethanol has got a boiling point. So the boiling point of ethanol at standard pressure is equal to what? 78 degrees Celsius. And then the boiling point of water is 100 degrees Celsius. So which one is greater than the other? It's 100 degrees Celsius. So definitely ethanol will boil first. So you come here and say, therefore, ethanol will boil first. Therefore, ethanol will boil first. Why? Because it has a lower boiling point, because it has a lower what? Boiling point than water. So the one with the lowest boiling point is the one that will boil first. That was what you were supposed to answer there. Now let's go to question number 4. Question number 4, also this one they like it. They like asking about strontium. Maybe it's because they relate much. When it comes to Christmas time, when it comes to New Year, you pop out some firecrackers. Those red lights that you get to see, it is a product of what? Of strontium. So we are saying strontium is an element on the periodic table in period 5 and group 2. And then they are saying that the 4 isotopes of strontium have isotopic mass numbers of 84, 86, 87, 88, and the relative abundance of each isotope is given there respectively. Now they're saying define an isotope. We know that an isotope, these are atoms of the same element that have the same number of protons, but different number of what? Of neutrons, but different number of neutrons. So there we are saying that an isotope, it's atoms of the same element that have the same number of what? Of protons, but carrying the different number of neutrons. And then now they're saying write down the symbol of strontium. The symbol of strontium is just Sr. So strontium is Sr. How many valence electrons does strontium have? Here they mention that strontium is in group 2. All group 2 elements, they've got what? 2 valence electrons. So strontium has got what? 2 valence electrons. Now they're saying compare the atomic radius of strontium and magnesium. We need to compare the what? The atomic radius of strontium and magnesium. We also use our periodic table to get to look at the what? At the way strontium and they are actually arranged on that periodic table. So you would know that the atomic radius actually increases across the what? Across the atomic radius, it decreases from left to right, and then it increases down a group. So we can see that from group 2 elements, we have got strontium here, and then we have got magnesium there. So magnesium is on top of strontium. So magnesium has got a what? It has got a smaller, this one has got a smaller atomic radius. While strontium has got a what? A larger atomic radius. Why? Because we are saying that electron shells, they increase down the group. Hence, therefore, the number of electrons, they become far away from the nucleus, where the atomic radius is a measure of the distance between the nucleus and the what? And the outer electrons. So our strontium will be having a larger atomic radius than magnesium. Why? Because it is lower on the group than magnesium. So here you are just supposed to come and say that magnesium has got a smaller what? Atomic radius than strontium. Magnesium is a smaller atomic radius than strontium. They just wanted you to compare the two atomic radiuses. There was no need of explaining. But the explanation is that strontium is lower on the group than magnesium. And we know that the atomic radius increases down the group. Now they're saying calculate the relative atomic mass of strontium. Relative atomic mass of strontium. Here we would use the isotopes that are given there. So we are going to use the relative what? Abundance of each isotope and then the mass number of each isotope to find the average relative what? Atomic mass. So what we are going to do there, we are just going to find the average. So 4.5, we're just going to say that average relative what? Atomic mass of strontium was going to be equal to, we've got the one that has got 84 times 0.56, that is its abundance, plus the one that has got what? Let's just get to check on the information given. 86, and then it has got a relative abundance of what? Of 9.86, 9.86%. And then we have the other one that has got 87. We have the one that has got 87, and then its relative abundance is what? It's 7%. And then finally, we have the one that has got 88, and its relative abundance there, it's what? It's 82.58%, 82.58%. And then we now come, we divide by what? We divide by 100%. And then we're supposed to find the average atomic what? The average atomic mass being equal to 87 point what? 0.71 grams. 87.71 grams. Now let's go to question number 5. And let's see what they are saying there. So question number 5 is saying an unknown organic compound has a formula of CXHY OZ. The molar mass of the compound is 88 grams per mole. Now they're saying define the empirical formula. This is the simplest whole number ratio. The simplest whole number ratio of atoms. The simplest whole number ratio, an empirical formula is the simplest whole number ratio of atoms in a compound. That is the empirical formula there. Now let's hear what they are now saying. They are now saying that a 2-gram sample of this compound contains 1.09 grams of carbon and 0.18 grams of hydrogen. Calculate the mass of oxygen there. So the total mass there, it's 2. And then the one for carbon is given, the one for hydrogen is given. So for oxygen, it will be the difference. So the mass of oxygen there, it will be the difference, which is just 2 grams minus 1.09 minus 0.18. And it was going to be equal to, we punch in our calculators, we're going to get 0.73 grams. That was the mass of oxygen there. Now they're saying calculate the empirical formula of this compound. So I usually advise that we just get to draw a table there, and then on our table we are going to list down the elements that we have for that compound, and then we are going to list down the mass composition of each, and then calculate the number of moles which is mass divided by molar mass, and then we are going to what? To calculate the simplest ratio. That simplest ratio is the one that gives us the what? The empirical formula. From what we have defined our empirical formula as. So the elements that we are having there, what are the elements that we are having? We are having what? We are having carbon, we are having hydrogen, and then we are having oxygen. The mass composition of what? Of carbon, we can assume that we are having what? Or else we take the basis of 2 gram sample. So we are having 2 grams of what? Of carbon. If we are having 2 grams of carbon, we are having 2 grams of our sample, and then carbon there, the mass of carbon there is given as 1.09 grams, and then the one for hydrogen is 0.18 grams. The one for oxygen we calculated 0.73, and then the number of moles, we just get to say mass divided by the molar mass. Molar mass of carbon, or else atomic mass, is 12. So if I divide 1.09 divided by 12, 1.09 divided by 12, it was going to give me 0.09 0.0908, and then if I divide 0.18 divided by 1, it will be just 0.18. And then if I divide 0.73 divided by the one for oxygen is 16, so it will be 0.73 divided by 16, you are going to get 0.04 5625. Now we divide throughout by the what? By the smallest number, or else by the smallest number, which is 0.045625. Here we were going to get 1, and then if we divide 0.18 by that, we're going to get a ratio of what? We're going to get 4, and then if we divide 0.0908, if we divide it by 0.045625, punching my calculator, I was going to get 2 there. In terms of whole numbers, we need to leave these in whole numbers. I know you might get 2 point something, 4 point something, but you just get to take the whole number. So this becomes the what? The simplest whole number ratio, which is saying C2, H4, and O. So that becomes your empirical formula there. And then they're saying determine the molecular formula of this compound. The molecular formula of this compound, you were given the what? You were given the molecular mass. Mind you, were given what? 88 grams per mole being the molecular mass. And then now you now know the what? The empirical formula there. Knowing the empirical formula, you know that the atomic mass of this empirical formula will give you what? It will give you 12 times 2 plus 4 times 1 plus 16. And this was just going to be equal to what? 24 plus 4 plus 16. So this was going to be equal to 44. And then we know that the molar mass that is given there, it's equal to 88 grams per mole. So we now want to know the ratio in between these two. So you would actually come and divide by 44, and this was going to give you 2. So you now know that the molecular formula, which is the actual ratios now. The molecular formula would be equal to 2 times the simplest ratio, which is C2H4O. And then this one was going to say 2 times 2, 4. So it would be C4. And then 2 times 4, it is 8. 2 times 1, it is just what? 2. So that was going to be what? Your molecular formula there, which is the actual what? The actual ratio of your atoms. Now let's go to the following question, which is question number 6. Question number 6 is now saying that in the reaction below, 3 grams of sodium carbonate were reacted with hydrochloric acid solution, and then there was an effervescence which was observed. So this is the reaction. So definitely the effervescence was for this gas, which is carbon dioxide. Whenever we have got a reaction and we are forming a gas, that gas definitely would actually get to what? To have some bubbles, those bubbles are going to effervescence out. And then now we are saying write the name and the formula. They are saying copy and balance the chemical equation first. So we needed to balance this chemical equation. So balancing the chemical equation, you are balancing the number of atoms. The number of atoms, sodium atoms, this side are 2, this side they are also going to be 2. Therefore, the number of chlorine atoms would be 2. So you multiply by 2 this side, and then you have got 2 hydrogen and 2 hydrogen. The number of oxygen atoms, they are 3, and this side they are also 3. And then the number of what? Of carbon atoms, they are 2, and also this side they are what? They are 2. So you are just supposed to have what? 1 mole of sodium carbonate reacting with what? With 2 moles of hydrochloric acid to form 2 moles of sodium chloride plus 1 mole of carbon dioxide plus 1 mole of water. That is how you were just supposed to what? To balance there. So that was how you were supposed to balance. You are just balancing the number of atoms on the left hand side. They are supposed to be equal to the one that are on the right hand side. Now they're saying write the name and formula of the substance that causes the effervescence. We said it's what? It's carbon dioxide. The carbon dioxide gas there. You're just supposed to write CO2. That is the formula. And then the name is what? It's carbon dioxide. Because they said the name and the formula. So it's carbon dioxide gas. And then now they are saying from the chemical equation, write down the formula of 2 compounds that are covalently bonded. So covalently bonded, covalent bonds, they occur between a nonmetal and a nonmetal where there is electron sharing, where they share these electrons. So here we have got what? For non-metal, we have got hydrogen and chlorine there. So HCl is covalently bonded. We have got carbon dioxide and what? And oxygen. We have got carbon dioxide and oxygen. So we have got carbon dioxide there. We have got carbon and oxygen. And then also this one, it's hydrogen. It has got hydrogen bonds, but it's covalently what? Bonded. Also, you are going to write what? Water there. So you would choose any 2 of these. Ionic bonding occurs between a metal and a non-metal. Now, let's try to identify a metal and a non-metal that are bonded there. We have got sodium and the carbonate. So you are just going to say sodium carbonate. And then we have got sodium and chlorine. So sodium chloride. So these are just 2. And then now they are saying draw the Lewis dot diagrams for what? For carbon dioxide. So for carbon dioxide, the Lewis dot diagrams, we are just representing how carbon dioxide is bonded in terms of the dots. They represent the what? The lone pairs. So the lone pairs here were for what? For oxygen. Oxygen carries what? It carries 6 outer what? Outer electrons. And then 2 of them would be shared with those for what? For carbon. So carbon brings 4, and then it will share these 2 with the other, 2 with the other. So maybe I was just supposed to do it like that. And then this side, I would also have that. So the other way to represent this is to just write oxygen and then a double bond there, carbon, double bond, oxygen. And then on the oxygen outer, you show these lone pairs. You show these lone pairs. That is a what? A Lewis dot diagram for carbon dioxide. And then for water as well, you come, you say you have got your oxygen, and then it is bonded to what? It is bonded to hydrogen. It is also bonded to another hydrogen. And then we are left with what? With those. So you are going to see that here we are going to be having what? Single bonds, because we are saying that hydrogen brings 1 outer valent electron that is going to bond with oxygen, as well as another hydrogen bringing 1 outer valent electron. And then this one would be left with what? Because this one carries what? 6. So it will be left with 2 lone pairs to make them 8. So you were just supposed to say oxygen, single bond hydrogen, oxygen, single bond hydrogen, and then you show these what? these lone pairs there in that format. So that is how you were just going to draw the what? The Lewis dot diagrams. This is for your water and this is for your carbon dioxide. And then now they're saying calculate the molar mass of sodium carbonate. The molar mass for sodium carbonate. Let me just get to rub this because we have already done it. So the molar mass for sodium carbonate would actually get to say that sodium has got 23. The atomic mass for sodium is 23. So you are going to multiply by 2 there. 23 times 2 atoms plus you have got carbon, which is 12, plus oxygen, that is having 16 times 3. So this was going to give you a what? A total molar mass of 106 grams per mole. That is how you're calculating the molar mass of sodium carbonate. Now they are now saying that calculate the number of moles of the 3 grams of the sodium carbonate used. So the number of moles, we know that number of moles is equal to what? Mass over molar mass. We have calculated the molar mass already and the mass is given. So you would say 3 divided by 106. This was going to give you what? This was going to give you, if you calculate there, you're just supposed to get 0.028 moles. And then that was the number of moles of what? Of sodium carbonate in 3 grams. Now they're saying determine the number of oxygen atoms present in 3 grams of what? Of sodium carbonate. So we have got 0.028 moles. We know that 1 mole of any compound has got 6.022. It has got 6.022 times 10 to the power 23 atoms or else entities. And then now we have got this number of moles. So here we have got 0.028 times 6.022 times 10 to the power 23, being the total number of atoms or entities that are there in sodium carbonate. But we know that in terms of atomic ratio, we have got 3 atoms of what? Of oxygen there. So we later count and multiply by 3. And then the total there was just supposed to be equal to what? If you use your calculators, you were supposed to get a total of 5.11 times 10 to the power 22 oxygen what? Oxygen atoms. That is how you calculate it. You just say that the number of moles times the Avogadro's constant, number of moles times the Avogadro's constant times the atomic ratio of that element within the what? Within that compound. Now we then go to question number 7. Let's hope we are going to finish, guys. They are saying in the reaction below, magnesium ribbon reacts with excess hydrochloric acid according to the following balanced chemical equation. When the reaction is stopped, the plunger in the syringe remained in the position as shown in the diagram below. So this is the diagram that they've given you. They are saying define 1 mole of substance. 1 mole of substance simply means the amount of substance, that contains the amount of substance that contains the number of entities equal to 12 grams of what? Of carbon 12, equal to a 12 gram of carbon 12 what? Isotope. Or else the amount of substance that contains the number of entities which are equal to the Avogadro's number. That is 1 mole of a substance. That total amount of a substance that contains the number of entities that are equivalent to the what? To the Avogadro's number, or else to the 12 grams of a carbon 12. Now they are saying write down the volume of hydrogen gas collected in the syringe. So we now need to use this syringe to calculate the volume. So let's use, you can see that this is where we have got 50, and then how many parts are equivalent to 50? We have got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 parts equal to what? To 50 cubic centimeters. So 50 cubic centimeters is equivalent to 10 parts. So we know that 1 part would be equivalent to what? It would be equivalent to, if I divide there, it would be equivalent to 5 cubic centimeters. Now you can see here that I'm on what? Number 9, part number 9. So this is just equal to what? If you say 9 times 5, it will give you what? 45 cubic centimeters. Or you would have said 5, 10, 15, 20, 25, 30, 35, 40, 45. So the volume there, which is represented by that syringe, is 45 cubic centimeters. Or you would have just came and divided this to leave it in what? In decimeter cubed. That was going to be your choice. Write down one physical observation that indicates that a reaction is taking place. So you can see that from the reaction, the equation that is given, they are saying that magnesium is reacting with hydrochloric acid to form what? Magnesium chloride and hydrogen gas. And from that diagram, we can see some bubbles. So a physical observation that you would actually get to look for is the what? The bubbles of what? The bubbles of hydrogen gas. So you would actually get to say gas bubbles. Once you start seeing some the gas bubbles, it shows that we are forming hydrogen. So the reaction is actually what? Taking place. Let's get to say that you have just mixed your dilute hydrochloric acid and magnesium. You want to know if the reaction is occurring. You need to start observing the gas bubbles. Once there are gas bubbles, it shows that hydrogen gas has been formed. Now calculate the number of moles of hydrogen gas formed at STP. At STP, we know that 1 mole is equivalent to 22.4 decimeter cubed. Now we've got what? 45 cubic centimeters. So the volume of what? Of our hydrogen gas is equal to 45 divided by 1000, which is equal to 0.045 decimeter cubed. So 0.045 decimeter cubed occupies how many number of moles? So we can say number of moles is equal to the volume of gas over the molar volume. So the volume of gas is 0.045 divided by the molar volume, which is what? 22.45, 22.4 decimeter cubed. So you would see that the number of moles that you are going to get there, which were occupied by hydrogen gas, were supposed to be equal to what? We're just supposed to be equal to, let's use our calculators, we're going to get 0.002 moles. So after using your calculators, you're going to get this number of moles. Now they're saying determine the mass of the magnesium ribbon used. How do we calculate the mass given that you now know the number of moles and you know the what? They're saying determine the mass of the magnesium ribbon. So the magnesium ribbon here, let me just get to rub here. So we can actually get to use the reaction to know the mass or else the molar ratio. After knowing the molar ratio, we can actually determine the number of moles of what? Of magnesium that are formed. After that, we can use the formula, which actually says what? Number of moles are equal to mass over molar mass. So 1 mole of magnesium is forming 1 mole of hydrogen. So if I know the number of moles of hydrogen, I simply also know the number of moles of what? Of magnesium that are reacting. So number of moles of hydrogen are equal to number of moles of magnesium that are reacting, which are equivalent to what? 0.002 moles. Those are the ones that we have calculated there. So what is the mass? So you can say number of moles is equal to what? Mass over what? Over molar mass. Because we are looking for the mass of what? Of magnesium that reacted. So the mass of magnesium that reacted would be equal to what? To the number of moles times the molar mass. That becomes 0.002 times the molar mass of magnesium. What is the molar mass of magnesium? We know that the molar mass of magnesium is 24 grams per mole. So if we multiply, we're going to get what? A mass of 0.048 grams. That was the mass of magnesium that reacted. So that was the end of our question paper, which was out of 100 marks. So thank you guys for your patience. Let's actually meet in the what in the next coming videos. We shall continue to do revision. We shall revise up until we've actually exhausted or else tried to exhaust all the recent question papers that we can find. So we thank you guys for being part of us. Let's meet once again in the next coming videos for what? For Maths Zone African Motives. More light, guys, more winnings. Until we meet again.